Hi, I'm Mark Ryan. I'm a Principal ZPA Solutions Architect at Zscaler. I've been here for 9 years, and in that time I've worked with many global companies to migrate to a cloud-first architecture. Initially for public applications through Zscaler Internet Access, and more recently for private applications with Zscaler Private Access, as they move to a zero-trust network architecture and migrating to infrastructure as a service. In this session today, we're going to talk about lessons learned and ensuring a successful Zscaler Private Access deployment. But before we get going, just a safe harbor and talk about forward-looking statements that I might make during this presentation today, specifically around things like API and controls and implementing that. You should obviously consider those carefully before making any decisions to proceed. So let's talk about getting to zero trust network access. In this reference architecture, we show on the left-hand side the different data centers that an organization might have connected via MPLS, and in the top right-hand corner, their cloud services in AWS and Azure. Implementing an express route or a direct connect to extend my network from my data centers to my infrastructure as a service, to provide access to those applications or database replication and whatever. Within my data centers in AWS and Azure, I might have a zero trust network access connector, which connects outbound to the broker that sits in the cloud. And if I look down on the right-hand side, I've got my remote users, and in the bottom left-hand corner, I've got my internal users, and my branch becomes essentially a guest network. It provides access to the internet, and both those users, remote or in the branch, they connect to my stacks in the cloud, whether it's my internet security stack or the ZTNA broker to make those policy-based decisions to connect users to applications. Zscaler's belief is that the way that this should be achieved is that the ZTNA broker creates an outbound request to the broker in the cloud, and therefore your data centers become dark to the internet. There's no inbound connectivity into those data centers. And the policy is enforced in the cloud, and you get all your logging and reporting. And obviously then for anything that's not private, it passes through the internet security stack for scanning and visibility and control. So let's talk about implementing zero trust network access. Zero trust doesn't happen overnight. It has to be a process. We believe the way to achieve this is to start with a crawl. Provide identical access to what users have today. That might mean they're coming onto your network via a VPN, or they're physically on your network. And when you implement zero trust, we should do that in a way where users don't perceive a change. It's identical to the way they access the applications today. But zero trust starts to give us visibility. And over time, we can use that visibility to start to walk. We can restrict access to the critical applications. Today, users are on my network and they can access everything. Now I've got visibility of those applications they're accessing. I can start to question, why should Mark have access to SAP? Great, now let's say only the people that need to use SAP can have access to SAP. So I start to restrict access to those critical applications, but I don't know what I don't know, so I continue to provide access to all the other applications. As we start to identify more applications, we can start to classify and build policy around those applications and start to build up that policy layers of who can access which of those applications from varying levels of criticality. And again, continue to access the things that I don't know about on my network. And over time, as we start to fly and we've classified everything, I can start to build that application control and that access into the development lifecycle. I can start to empower my engineers, my developers, as they're writing applications and they're building their CloudFormation templates to deploy applications into AWS or building templates to deploy to Azure, that they consider the access mechanisms that we're provided through ZTNA to give users access to those applications, only those applications, and build security into that process. And also great with American politics. I know some people either like or loathe Donald Rumsfeld, but I do like his quote though. The first time I heard it, I thought, yeah, that's just silly. But as I've thought about it over the years, I know it's true. there are known knowns, there are things we know. There are also unknown. There are also known unknowns. That is to say, there are things we do not know. And then there are the unknown unknowns, the things that we don't know, and we don't know. And it's very difficult. And I think that's the challenge with network access and network applications. There are so many applications on my network, I just don't know what they are. I'm sure if you even ask the right questions about security and policy, even if you don't like the answer, that's okay. But then you can start to build an architecture that works for you and report on it, and that's how we implement that policy. We all know we have Active Directory in an organization. We might even know the locations of every domain controller in the Active Directory and how loaded they are and which users they serve, etc., etc. I mean, these are our known knowns. We also know there are a lot of applications in the organization being used day to day, without which the organization might collapse. Some process control, if it's a bank, it might be an access database running on a PC under a trader's desk, which runs some complex modeling that everyone relies on. Yes, I know, these things exist, but these are known unknowns. These are things that I know that I don't know. I don't know about every application that might be running under someone's desk. There might even be applications hard-coded to use an IP address for access. You might know what they are, or you might discover these over time, but you have to build a policy to streamline troubleshooting it, understand, okay, there is this application that's being accessed by an IP address. There are also applications which should be turned off before Y2K, for example. They're never accessed directly, but there is a client running on some machine which updates periodically, makes a call once a month to this odd application. It's an unknown unknown. It's something you can't necessarily ever find out, and you don't know the questions to ask people because you don't know who the people to ask about this odd application that might be run periodically. Another example with identity and Active Directory, you might believe all the users are in one domain for authentication, domain.com. But AD has evolved over time, and legacy domain access might still be existing for, company.intra or internal.nt4. You might need to factor this into your wildcard application policy. Connectivity from the connectors can become a problem as well. So we need to start to think about, what does application discovery need to look at? Just-in-time application access means, discover the application just in time as the user accesses the application, and we'll find the shortest path to the access. And when we discover the applications, we'll find out where they are and how they are accessed. Active Directory is complex, and we might need to add additional domains for authentication. We might need to add additional domains for our auto-discovery process, just to be able to know about all of the applications as users access them. We need to specifically think about the domain suffixes and search domains. There are lots of applications that you might think are being accessed by an FQDN, but actually in reality there's something in the underlying code that's trying to short name and relying on the DNS suffix that your DHCP server is giving out. And so we need to make sure we replicate that both in the client configuration for the search domains, but also in the wildcard discovery for those applications to access. And then we need to implement a policy as we troubleshoot that application access. Is the application being accessed by an FQDN or a short name and an IP address? Maybe that's even in the payload that's delivered from the application. And by that I mean I go to server.company.com and access an application, and that response, the payload that comes back from that server, says just access me as server on port 389, for example. And that means you need to think about, how do I add that domain suffix, add that search domain, make sure that matches an application segment, and potentially go back and then fix the application and make sure that it's advertising an FQDN. And it's an iterative process. Let's solve the problem, and as part of crawl we're making sure that application access just works, understand why the application access isn't working, and then fix it. And that might be an immediate fix by allowing the IP address to work through Zscaler private access, but it may then be a longer term fix by changing the application to work by an FQDN. Or it may be that you enable it to work via a short name and then you go and fix it to work by an FQDN. An FQDN is where we want to be in the end, but we need to be able to counter and work for all services. And then think about the application connectivity, because when the users are on the network, there might be an ACL that says anybody that's on my network can access the application. There might be something that says that ACL might include my VPN range to come in and allow access to that application. Well, of course, with Zscaler Private Access, the user isn't getting an IP address on the network. So those kind of firewall rules might not necessarily be in place. The ACLs might not be in place on those applications. Similarly, we need to make sure the connectors are deployed in a way that they can connect outbound to the Zscaler cloud, and making sure you're following the best practices for those, that we're not seeing requests getting dropped on the firewall or blocked on that outbound access. So making specific concerns and investigations onto, are all of my connectors being able to connect to, number one, all of the applications, and number two, the Zscaler cloud, is important to make sure everything works. So maybe it's worth just having a reiteration of the Zscaler Private Access architecture. The Zscaler Private Access architecture is an inside-out connectivity, meaning the connectors, both in AWS and Azure, connect outbound to the Zscaler cloud. My physical data center connects outbound to the Zscaler cloud to the broker. And so all of those connectors need to be able to talk to all of the Zscaler brokers, because no matter where your user is in the globe, as I'm traveling around the globe, I will always connect to the closest Zscaler broker or the Zscaler Zen that I'm closest to. And it's that Zen that therefore brokers the request for my application access. So if I'm in Hong Kong and I'll go to the Hong Kong node and I'm accessing an application in London, my connector in London needs to be able to connect to Hong Kong. And if I then get on a plane and I go to Sydney and access the same application, that connector in London needs to be able to access the connector in Sydney. And move to Sao Paulo, it's exactly the same. So it's really important to understand that Zscaler publishes our IP ranges for where all of our connectors are, both today and going forward, that we might open up more data centers and give all of that. That's on our published page. So it's important that you say all connectors can connect outbound to all of the Zscaler brokers and the Zscaler network. Similarly, those connectors also need to be able to access those applications that are published behind them. So making sure that the access control lists from the connectors to the applications are in place. And then, there might be a situation where an application is only accessible from the physical data center. And you need to make sure that that application that is only accessible from the physical data center is not advertised from AWS or Azure, because if you're using the wildcard discovery, all connectors could be part of that wildcard discovery. And if that application is only available from the connectors in my physical data center, then maybe that physical data center's connector might be excluded from that discovery process because of the geographic location of the user. So having some considerations around where your users are, those applications, making sure they're advertised correctly is really important to make sure that applications work correctly. I want to make sure that Zscaler app is deployed, and Zscaler app is deployed in a supportable way. And what I mean by that is, the latest version of Zscaler app, 1.5.2 and above, supports packet capture, for example, on the client, and that is going to really enable you to troubleshoot Zscaler private access applications. There's also additional functionality. You need to make sure that Zscaler app is deployed in that supportable way if you're running Zscaler Internet Access. Is it running in tunnel mode? Is it running in the lightweight filter mode, which is our recommendation, rather than the tunnel with local proxy, which absolutely is a supportable mechanism, but you need to consider how that tunnel with local proxy mode for Zscaler Internet Access might affect the Zscaler private access applications, and making sure that it's a supportable mechanism, the right bypasses are in place and everything. And then the same is true for browser-based access. If if we've not got a client and we want to uh, give users to, maybe it's a business customer or a third party, that the application is delivered over the browser-based access. We need to make sure that the short names and domain suffixes are all configured correctly. And if an application is only available by an IP address, then we advertise just that IP address. And I can't state this strongly enough. It is not a good best practice to advertise 10.0.0.0/8 on ports 1 to 65535. You're opening up your entire network, and that's obviously going to cause a potential security problem, and it might solve your initial problem with an application not working, but really it's a hammer to crack a nut, and it will cause you further problems later on. So if there is an application that can only be accessed by an IP address, then you should only advertise that one IP address for the one port or the number of ports that application is on to make sure that that application works. And so this is that iterative process. If you discover something that doesn't work by an FQDN and you identify that it only works by an IP address, then advertise just that IP address and not a range. And the other thing that I can't emphasize strongly enough is never, ever, ever advertise an IP address and UDP port 53, because everything that Zscaler is doing with private access is starting off with intercepting that DNS request, and if you start to advertise an IP and UDP 53, then which one takes precedence, the application port 53 or Zscaler app intercepting port 53 for your internal namespace? And so we need to make sure that works correctly. And then the other recommendations that we'd say is use the log streaming. You can connect this into your SIEM. That'll give you longer term log storage as well as diagnostics, and I've seen some really interesting things customers have done with pivot tables and reports to get that diagnostics working and understand what applications are working, what applications are not working. So the four pillars of that initial deployment. Now we're starting to look in. How do we scale this up and start walking? Number one, identity is key to Zscaler trust. Number one, identity is key to a zero trust network access architecture. We need to understand who the user is. We need to understand what how they authenticated, and we do this through SAML. So SAML authentication is for the users. That can be against Azure AD, it can be against Okta, OneLogin, Ping Federate. We can do multi-factor, user, device-based authentication. All of those are features of the identity provider. We consume identity, and we can consume all of those attributes, and you can obviously extend those attributes later on to include anything that you can take from the person document or the authentication process, and you might add to those later on. But conceptually, being able to say it's Mark Ryan on a corporate device that did device-based authentication against Azure AD, and I also did user-based authentication with multi-factor, and return the groups that I'm in as well as the location that I authenticated from, is really powerful to build a really strong, tight, robust policy. But you don't need to do that day one. You might just say it's Mark Ryan and he's in group A, provide him access to those applications. But over time, you can build that up, maybe for your most secure applications, to say all of these things have to be true, being on a corporate device, etc., with CrowdStrike running on it, and make sure the firewall's running and it's certain registry keys that I can then start to build a policy on. Access. Do I need to give access via Zscaler app? Or can I give these access to these applications just with the browser? The browser might be sufficient for any HTTP, HTTPS application, and say that I don't need to roll it out, the Zscaler app, to everybody. Typically, we're going to do it for third parties and partners, but you might also do it for some of your users accessing from a non-corporate device. And then use Zscaler app for everything else. And just remember that traffic from the server to the client, initiated from the server to the client, is not supported. Anything that is client to server, client initiated request, server response is supported. Plan your connectors. The connectivity is really important. Place the connectors by the applications where there is an internet gateway. Place it in the infrastructure as a service. Place them in a specific availability zone in a specific region. Maybe doing in their own VPC with VPC peering. Treat them as a different DMZ, but make sure that the connectors have all of the access they need to the applications. Make sure that the connectors have all the access they need to the Zscaler cloud, and build them in a scalable way. There should always be a pair of connectors in every data center where you place them, and do not create one connector group across multiple data centers. Create a connector group per data center. And then in terms of the applications, start with the wildcard domains on all ports. Avoid IP addresses, as I said, and avoid UDP port 53. It is really important that we do not see DNS traffic advertised through Zscaler Private Access. And then if you've got a split brain DNS, company.com is your domain, both internal and external, then you want to put in bypasses for anything that's resolvable for the internet. So you might have your wildcard star.company.com, but then you'd put in a bypass for www.company.com because you want that to go through the internet access service, or you want it to go direct. You don't want that coming through Zscaler Private Access. That list might be you might require to get a dump from your internet DNS resolution and create one application segment which is called public DNS or public internet, and bypass all of those. You should also do that for things like Skype for Business. Part of the auto discovery process for Skype or Teams is that it resolves internally and externally. So you need to plan that, and we have some guides on how to best implement Skype for Business and Teams with Zscaler Private Access. So this is how it works. Keep it simple. Start with a simple application discovery with a wildcard. Here is my domain, star.welshgeek.net, port 1 to 65535 for both TCP and UDP, using an auto discovery. It's in an auto discovery segment group and dynamic discovery server group. I've put in my DNS search suffixes. welshgeek.net is my search suffix. If I try to access something as a short name, Zscaler Private Access and Zscaler app will automatically add that that suffix to make sure it's resolvable. Now this tick box, domain validation in Zscaler app, really important, because if you've got multiple domains, it's going to make sure that all of those domains go into Zscaler app and Zscaler Private Access before then trying to resolve them externally. And indeed, you probably don't want that to happen either. So this tick box came in the 1.5 release, 152. So please make sure that you are using that. We've seen a couple of different scenarios where you might be on a hotel Wi-Fi, for example, that instead of returning an NX domain, which it should, resolves an A record or something for something that isn't resolvable. So it's important that you use this feature to go forward. I have my dynamic server group. The dynamic server group says, yeah, I'm going to use dynamic server discovery. We're going to, when a request is made, we're going to figure out which connector can resolve it, and dynamically, just in time, connect the user to the application. Use a single server group for discovery as much as possible, unless there are those scenarios, as I said, where an application is only available from a certain connector, and therefore you'd use a specific dynamic server group with just that connector in place. In this example, I've got my two connector groups, one in Milton Keynes and one in AWS, associated with that server group. So here are my connectors. I am not doing what I said my best practice was, which was having a pair of connectors in each connector group. But I do have one connector in AWS and one connector in Milton Keynes, and they are different connector groups because they're separate locations. And then I'm going to start with my standard access policy that says all users allowed access to all applications. And this is going to ensure that any connector can be used for access to an application. All connectors have access to all applications, whether they're in AWS or Azure, and the dynamic resolution is just going to work, and there's no access policy breaking things. So I make sure that I'm providing exactly the same access through Zscaler Private Access as I had without Zscaler Private Access, whether on my VPN or on my physical network. And make sure that everything is working, all my users can access all of my applications based on this, and then over time we can start to look at building policy later on. Become comfortable with Zscaler Private Access. ZPA will give you visibility of every single TCP and UDP connection a user makes to an application which is behind the wildcard, obviously excluding the bypassed applications. So an error might be for a user accessing a server.company.com on TCP port 80, but because the server isn't listening on it, you're going to see an error. It could be a legacy application. It could be part of the application discovery process within itself. So first it tries port 80 and then it automatically tries port 443. This can give you some really great insight into how applications perform and potentially why applications aren't working the way you expect them to work, which may have always been the case or invariably will have been the case. Zscaler Private Access is going to give you detail that you just didn't have visibility of before. Equally, you might find an application works for some users and not others, which could indicate a problem with either the one group of users are using connector A and another group of users are using connector B, and you need to look at the ACLs on the connectors as well. You can both drive policy from application segment, defining the application specifically, which ports it should be open on, and which connectors should advertise it, and that can remove those errors that you might have seen. So the discovery process produces some errors. Let's remove those errors by creating an application segment just for that application, just on the ports that it needs, and therefore we'll stop seeing the errors for those other ports that it's trying to connect to. You may succeed in reducing all of those errors to zero. You may define applications to bypass because they're only available on the internet, or by removing those port definitions that aren't necessary. You may get down to zero errors. But I'd also say there's no need to think about an error as something you need to go and fix. Errors by their very nature, and I think human nature is I want to solve that problem, but just because I see a bunch of errors that say the connection timed out doesn't mean to say that there is really a problem. Zscaler Private Access might fail over, the application might not be listening on that port. Maybe you can identify those, maybe you can fix the application, maybe you can remove those ports and get down to zero. But I think my recommendation is don't try and solve every single error. Otherwise, it could be a problem that just keeps on going. Errors provide a detail of application access and functionality, and you might then need to go and change the application in itself. And policy can be changed or accepted. You just accept that some of these errors are going to occur, and you can use these drill downs to understand a bit more about what's going on with that application. So think about that troubleshooting process and build that into your support mechanism. I would advocate, as part of implementing Zscaler, that you should make sure that your administrators have done some level of the training that Zscaler provides, the CBT training, get yourself certified, and then put in place a process. I'm not going to spend a lot of time here going through how to troubleshoot every single application, but I would put in place a process around making sure that you can get the Zscaler app logs, making sure that somebody who's troubleshooting can either has access to the UI or the log streaming service logs. Potentially, you might need to take packet captures from Zscaler app or the connector. And also think about accessing from the client or the connector. Can you do the DNS resolution? Can you do a netcat or a telnet? From the connector and show that the connection's working from each of those connectors that's in that discovery process. The output of that is, is DNS resolution working both on the connectors and on the client? Is Zscaler app intercepting the request? Are the suffixes being appended? If they are, and is the connection, the connector being used, being selected correctly? And then potentially you might want to look at that payload, the data that's coming back from the server. So the packet capture helps with that. And if you see the payload coming back from the server and it says, hey, connect to me on this IP address, then it's giving you the indicator that there's something within the application, not necessarily something in the configuration or the deployment of Zscaler. So the results of that are potentially changes to the application segment, maybe adding an IP address, changes to the policy. Oh, we saw that the user was blocked because of policy, not because of connectivity. Maybe it's the DNS suffixes, and that could be the DNS suffix because of an Active Directory lookup. It could be a missed DNS suffix because of the way the application segment is working. We might find that we need to change the connector groups that are being used for one application, because rather than discovering across all connector groups that are deployed, we need to tighten it down to just using the connector groups that are closest to the application, maybe just in your physical data center. Maybe that means changing the server groups. Policy and application access are obviously things that are, I wouldn't say trivial to change, but if you've implemented a policy change and things stop working, then it's easy to pare those things back and start looking at that policy. A good example of the connector payload is something like SAP. SAP can be configured in a number of different ways. The right way to implement SAP, in my honest opinion, is that everything should be an FQDN, and you access, I access my SAP load balancer or the dispatcher process for SAP, and it returns connect to SAP database 1.company.com on port 3200. But a lot of implementations that I've seen of SAP, that dispatcher is the FQDN, but the dispatcher then returns the IP address of the actual database to connect to. And of course, making changes to SAP is a complex process and can have wider impacts. So that needs to be planned better. And so defining the application segment for the IP address resolves your immediate problem, but you might want to look at how you implement SAP and the changes you could make to the SAP service. Policy is still something I recommend keeping simple and leaving complex policy until all application access is proven. That way you're not troubleshooting policy versus access. If you find a problem with an application not working, ensure it's not relying on another application segment, for example Active Directory for authentication, and you haven't restricted access to Active Directory. Build application groups and apply policy. Grant access based on SAML attribute, posture of the device. Note the policy can be an AND or an OR by clicking on the AND or OR on the right hand side, as you see here. You might want to think about multiple rules to get the right policy you want. Think about this very similar to a firewall rule base. You're going to build it up with maybe multiple allow rules per application based on different criteria. And then you'll start to then once you've built out those multiple allow rules, then you might put a deny in for that application. One thing I'd recommend: do not define Active Directory as an application. Leave that as the wildcard discovery. You can define Active Directory, of course, if you know where all your domain controllers are and all your ports, but it'll be a thankless task. Someone will add a domain controller, you won't know about it, and then you'll start to see some challenges going on. So my recommendation, use the wildcard discovery for Active Directory and define everything else. Define application segments, apply policy on segment groups, group the applications together and apply policy based on that. Apply policy based on those SAML attributes. Obviously, you can continue to extend those SAML attributes, the client and the posture. And then once you've defined, as I said, all of those different applications segments, you find an application segment, you might need multiple allow rules depending on different postures and different groups that you can't and or together. So you might end up with several rules for that application and then a deny rule to block all access if it doesn't match an allow. There is an implied default deny, and sometimes people forget that, and that can be a reason why application access isn't working. If you start going down the route of a allow for each rule, then you forget that there's a default deny at the bottom. DNS suffixes, and I talked about this a minute ago. DNS is the integral part of ZPA and Zero Trust Network Access. It's often a global namespace, so my suffix might be company.com. I have seen some organizations expand that namespace and consider things like EMEA.company.com, US.company.com, APAC.company.com, and then applying access to applications that are EMEA.company.com from those different, only from those connectors in EMEA. The US.company.com, I associate that with a connector group for just my US connectors, and the same for APAC.company.com. It starts to give me control as to which connectors are going to participate in that request. It also gives me visibility as well. And then I see customers start to build that out in infrastructure as a service and say, okay, aws.company.com or even region.aws.company.com for those applications that exist there, and only associating aws.company.com with the connectors in AWS. So I start to restrict and I can control. I can still say, a user can access an application in EMEA.company.com through my London connector and access an application.uswest.aws.company.com through my connector in AWS. And I'm not saying you have to go around and rename all of your applications. You can just CNAME the application segments for the real FQDN of the service. It starts to build policy. It starts to enable you to steer traffic in the directions that you want it to go, and starts to enable you to start to build policy on top of Zscaler Private Access and Zero Trust Network Access. So, talking about, we've now gone through crawl, walk, run, fly. What are the futures that I can start to do with this? So I can start to build ZPA into the development lifecycle. Consider how your applications are deployed, making sure that those applications, as your developers are building them, they're building their CloudFormation templates, for example, that the namespace that they're building those applications match your DevSecOps process, and building that into those connector namespaces and which connectors are advertising which applications. Build to scale, build to fail. Is kind of the mantra of infrastructure as a service. I should make sure that the connectors are in auto-scale groups, whether it's in AWS, Azure, GCP, or ESX, that they can horizontally scale, even if it's a maximum of 2. Obviously, the minimum we recommend is 2, but if you define an auto-scale group with a maximum of 2, it means that if you see a problem, you can just shoot one of those connectors. It'll destroy, it'll auto-scale back in and start to service requests. So you can build that scalability and failure process into your DevOps process. Log streaming into your SIEM, so you have, number one, extended logging past the 14 days that we provide in the user interface. but also the ability to cut those requests and understand, different pivot tables of who is accessing what applications. If you're seeing failures, being able to report on those failures and understand where those failures exist, and then they'll start to give you intelligence as to how you fix those problems. But equally, that feed into the SIM gives you visibility of who is accessing what applications. Um, and you can then start to build that access control policy for periods of no use. You can say, well, Mark hasn't accessed SAP for 3 months. Let's revoke his access. And if we've revoked his access, he can always ask for access again, and maybe that goes through a process. Maybe through a help desk ticket through ServiceNow to implement an API call to then provision access again and put him in the right groups through reauthentication. Zscaler Private Access API is something we're working on. ZPA was built on API. API is a fundamental part of how we've developed the platform, how we deploy connectors, how we deploy the broker services. We're going to start to open that up. And then we're talking roadmap sessions here, but the API being able to enable you to create application segments programmatically, create policy programmatically, pull provisioning keys for new connectors programmatically. So we want to start to open up the API, and then you can build that into your DevSecOps processes after we release that functionality. So let's just think about how we build that reference architecture. Again, here what we're showing, it's a bit of an eye chart, but here I've got my corporate data center on the right. I've got my AWS VPCs in AWS VPC. I've got Route 53 for my DNS in AWS. I've got Active Directory for my DNS in my corporate data center. I've got VPC peering between the different regions. In region 1, I've got 2 availability zones, and I make sure that I build my connectors in 2 different availability zones in that auto scaling group. In region 2, again, auto scaling group across 2 availability zones for my build to scale, build to fail. And then if a user goes to access an app, those 3 applications, maybe it's a web site with app3.domain.local, app2 in another frame, app1 in another frame, that request comes into the Zscaler Private Access Cloud. We identify the policy, we enforce the policy, and then we connect the user to the applications. So the user request to app3 comes over via the connectors in my physical data center. The request to app2 comes via one of the connectors in AWS. Invariably, that should happen from the connectors in region 2. And then the request for app1 comes via the connectors in region 1. And we select the best path, and the user has access to all of those applications, although presented in a single browser in multiple frames. So the recommendations: don't try to fly. Don't even try to run before you can crawl. Crawl, walk, run, fly. Take a systematic, programmatic approach to implementing Zscaler Private Access. Don't start with policy. I think we want to start to think about and benefit from all of those policy benefits that ZPA gives us. But if you start with policy, you're invariably going to start to have some challenges with that access. So start with access and build policy on later. And then remember, errors aren't bad. They're indicators for policy. Maybe they're indicators for policy of access, or indicators for the policy you build around which connectors should be used for a flow. Discover that user and application behavior. As you start to understand more about how users are accessing applications and how those applications work, you can start to change that behavior, either by education of the users or by changing the way the application works or the application definitions in Zscaler Private Access. DevSecOps is here. And Zero Trust Network Access is part of it. We can start to build Zscaler Private Access, the connectors, the application access into our DevSecOps process. And really start to embrace this and enable and empower our developers to build security and access into those templates that they're building out in their applications, and enable you to develop an application and rapidly deploy it and provide it to your users in a secure way. And hopefully Zscaler Private Access is part of that journey. So thank you very much for flying with me. Thank you very much for your attention. There's a reference architecture guide you can go and read on our public website. You can come to me or any of the Zscaler Private Access team to run an architecture workshop with you on how that's going to help you embrace cloud and transform your network access. If you've got the app from the session, please do rate the session, do provide me feedback, and thank you very much.